bases. The substances are characterized as bases if they have bitter taste. Means bases are those substances which are bitter in taste. The next is they are soapy and slippery in nature, just like a hand soap. Then we have it turns red litmus solution blue. So suppose we have a litmus paper which is red. Whenever we will put a base on red litmus, what it will do is it will convert it into blue. So this is one of the property of bases. Now, common bases we have metal hydroxide. So the metal hydroxides are generally bases. Suppose we have sodium hydroxide, potassium hydroxide, and aluminum hydroxide. We will see their formulae on the next pages. So these are three metal hydroxides. The metal here is sodium, potassium, and aluminum respectively. So many of these hydroxide, again, they have extensive use and application in the industry. So let us see their use. Here the first one is sodium hydroxide, which is also called as caustic soda. Its chemical formula is NaOH. Na stands for sodium, OH for hydroxide. Next, it is being used in the manufacture of soap, paper, textile. Then potassium hydroxide, which is commonly called as caustic potash. Its formula is KOH. So in alkaline means basic storage battery. It is used in the alkaline or basic storage battery for absorbing carbon dioxide. Next is we have calcium hydroxide, which is called as silicline. Its formula is COH whole twice. It is being used in the manufacture of bleaching powder, softening of hard water, and for whitewashing. Next, milk of magnesia or magnesium hydroxide. So milk of magnesia is basically MgOH whole twice, and its use is very important, which is it is being used as an antacid to remove acidity in the stomach. So whenever we are feeling acidity in our stomach, we will drink a solution of milk of magnesia. So it is basically anti-acid, means against acid. So it is working against acids. So basically it is a base. Then we have aluminum hydroxide, whose formula is AlOH whole thrice, which is being used as a foaming agent in fire extinguisher. So means to extinguish the fire. Next is ammonium hydroxide. So it is used for simply cleaning window panes, to remove grease from stains from clothes. So these are some of the uses of the bases. Next, there is Arrhenius theory of bases. So Arrhenius is a scientist which gave this theory for the bases. So according to him, he says that base are those substances which dissociate. So dissociate means simply broken down or broken down. So as bases are those substances which are being broken down or ionized to give hydroxyl ion. Means there is a base which is NaOH. Whenever I'll put it into water, I have to write this aqueous sign. So this NaOH will be broken down into OH negative ion and its anion which is Na positive. So this is what happens when we put any base in the aqueous solution or water. It will release this OH negative ions. Here we can also say calcium hydroxide, which is Ca2 positive and 2 OH negative will be released. Again, it is also releasing OH negative ions. So whatever the properties these bases have due to OH negative ions only. So this is because of OH negative only. Next, there is some exception which says that typically base have OH group. We can say NaOH, we are able to see COH, we are able to see AlOH whole thrice, and so on. But there are some exception in the formula, which is ammonia, that is NH3. It is a base, but it doesn't contain any OH group. But still it releases OH negative ions when dissolved in water. So how it happens basically, because whenever we dissolve or ammonia into water, what we will get is we will get ammonium hydroxide, which is NH4OH. And finally it will be broken down into NH4 positive and OH negative. So again we are getting OH negative in the solution. So according to Arrhenius theory of bases, NH4 positive is a base and NH3 is also going to be a base in aqueous solution. Next, again there is an exception which is CaO, that is calcium oxide, is a base. How it is a base? Because it again releases OH negative ion when dissolved in water. So here in CaO plus HO, we are able to see that it will get converted into CaOH whole twice, which is a base. Now, whenever we are putting CaO into water, first we will get this CaOH whole twice, which is calcium hydroxide, and because it is in aqueous solution, it will ultimately get converted into Ca2 positive and this OH2OH negative, and hence we are getting these two hydroxide ion in water. That's why it is also a base. So there are some specific bases which are soluble in water. So these are called as alkali. The most common alkalis are NaOH, sodium hydroxide, potassium hydroxide, and ammonium hydroxide. So all the alkalis means all the water soluble bases furnish or gives OH negative ions in aqueous solution, means on dissolving in water. Thus we can say that all the alkalis are bases, means all the water soluble bases release OH negative ions. It is as simple as that. But all bases are not alkalis, so it is not necessary that all bases are water soluble. There are some bases which do not dissolve in water. So NaOH and KOH basically are very strong alkalis or bases. They are water soluble and highly corrosive. A single drop, if a single drop falls on someone's hand, then it will basically burn the skin. So they cause blisters on skin. So we have to handle it carefully. Whenever we are using these bases in the laboratory, we must wear proper lab coat. We must have hand gloves and all in order to use these bases.